a fossilized leaf contains 19% of its normal amount of carbon-14. How old is the fossil to the nearest year? To the nearest. So this is very important. So you're told to approximate to the nearest year. So the information we are told to use is that 5,600 years as the half-life of carbon-14. So this is the information we are given. So what this is saying is that a fossilized leaf contains 19% of its normal amount of carbon-14. So normally, maybe it contains 100% of carbon-14 initially, but presently it contains 19%. So because of the content of or the percentage of carbon-14 present in it, so we're going to use this information to determine the age of the fossilized leaf. Now, but then you observe that there is a decay going on here, because initially there was 100%, now you have 19%, so there's a decay here. So because there's a decay, so we recall that the equation that models the decay rate is given by, you have n of t equals n naught e to the power negative kt. So we said n naught here is the initial amount, while t is the time. So but then looking at what we have here, we're not given any initial amount, we're not given anything, but we're just given a question here. So this is the question that we're told to solve. It says we're given a fossilized leaf is this, and then how old is this. So to put this in statements here, how old simply means find the time. How old? Find the time when the fossilized leaf contains 19% of its normal amount. So find t when n of t equals 19% of its normal amount, that is 19% of the original amount. So when it equals 19% of n naught, so find t when n of t becomes 19% of n naught. So that's what the question says. Anyway, before I move on further, we know that before we can use this equation here, we must know the value of k. That should be your aim. So before you can use anything, you must find the value of k. To be able to find the value of k, I need to first solve for k. Now when I know the value of k, I can now go on and find a solution to the problem we are told to do. Now to find k, usually you'll be given the information, this kind of information here. So the information we are given here is we're told that the half-life, so the half-life equals 5,600 years. So this is what we are told as the half-life. Now what this means is that because it's the half-life, it implies that at time t equals 5,600, then the number of atoms would have reduced to 1/2. So at time t equals 5,600, n of t would have been 1/2. So using this information here, I'm going to bring this down here. So n of t is n naught over 2. So write n naught divided by 2 equals your n naught, then e to the power negative k. So the time when n of t became n naught over 2, that is the time, is 5,600. So this becomes 5,600. So our aim now is to find the value of k. So to find k, what you'd observe is that you can divide both sides by n naught here. You can divide both sides by n naught. So this n naught goes off. So what you're going to be left with is going to be, so I want to write this as, this is 1 over 2 equals e to the power negative. So this is going to be 5,600 k. So which is the same thing as e to the power 5,600 k equals 1 over 2. So again, our aim is to find k. So we'll take the natural log of both sides. So this becomes the ln of e to the power negative 5,600 k equals the lane of 1 all over 2. So when you take the logarithm of this, so this becomes the coefficient. You have negative 5 600k. The lane of E equals the lane of half. So the lane of E becomes 1, which we already know the reason why. We know that already. So to find k, so this becomes negative 5 600k equals the lane of half. So to find k, we divide both sides by negative 5600, negative 5600. So this goes off, and then you have your k to be equal to, so the lane of half divided by the lane of negative 5600, we're going to have 0.000124. I already have this answer before, so don't get scared about how I obtained the answer. So now our k is 0.00124. So I can rewrite this officially as n of t equals n naught e to the power negative, so what we obtained was 0.000124 times t. So what the question says is find n of t, find time when n of t is 19% of n naught. So we want to find t when n of t, so n of t is 19% of n naught. Now 19% is the same thing as 0.19, because this is 19 over 100. Then of is the same thing as times and then n naught. So 0.19 n naught. So we want to find t when n of t is 0.19 n naught. So since n of t is 0.19 n naught, we're going to make a substitution here. So what you have is going to be 0.19 n naught, that is making a substitution here, equals, so this is n naught equals, then we have our n naught, then we have e to the power negative 0.000124 t. So immediately we know that n naught goes off here, so we could now have 0.19 equals e to the power negative 0.000124 t. So which we can also write as e to the power negative 0.000124 t equals 0.19. So to find t, again, we'll take the natural log of both sides. And when you take the natural log of both sides, what you have here comes here. So you have negative 0.000124 t, then the lane of E equals the lane of 0.19. So the lane of E is actually 1. So the final solution, what you're going to have here is going to be negative 0.000124 t equals the lane of 0.19. So to find t, we divide both sides by negative 0.00124 divided by negative 0.000124. So this goes off, and then your t is just going to be, that is your final answer, is going to be the lane of 0.19 divided by negative 0.000124. So when you punch your calculator for this, what you should obtain as your final answer is going to be, so the lane of 0.19 should be negative 1.66073 divided by negative 0.000124, just to save time. That's why I'm doing this. And when you divide this, this is going to give you 13393 years. So I decided not to use the calculator to save time. So the reason why I showed you the calculator before was so you could see the way I use the calculator to calculate all these things. Alright, so the final answer is 13,393 years. So that is what we're told to find. We're told to find how old is it to the nearest year. So the nearest year is 13,393 years, as we obtained below.